Assalamualaikum and hi, my name is Asrul Hayat bin Abdul Razak and my supervisor is Dr. Mastura binti Muhammad Taha. Today I'm going to present about my project entitled Development of Chemically Treated Sugar Palm Fiber Reinforced PLA Composite for Fused Deposition Modeling 3D Printing. Okay, so let's start with an introduction. So 3D printers. 3D printers is a technology that use technology to melt and deposit polymer and layer by layer to create a product. The most common use tech is fused filament fabrication and fused deposition modeling (FDM). The idea of 3D printers was discovered by Japanese named Hideo Kodama that at one time that he want to develop a rapid prototyping system, so he came up with an idea to print layer by layer of resin approach for manufacturing process. Then the 3D printers was introduced to market in 1990. Okay, in these studies, a filament is need to be created which act as ink for 3D printers, and to make this filament you need to use a extrusion process, and it will be used biocomposite material which is a mixture of sugar palm fiber and PLA as matrix. So composite and biocomposite, what's the difference between both of the composite material is a combination of two material, while biocomposite is instead of two material as the same type, it is one material of the biocomposite is naturally derived. Okay, next, to see whether the biocomposite material is better properties than pure PLA, an analysis need to be done. There are three analyses that need to be done in this study, which is thermogravimetric analysis (TGA), differential scanning calorimetry (DSC), and rheological study (RS). So this analysis need to be done is to characterize their properties to find a better specification so it can be suited with the 3D printed nozzle, and it will melt and deposit at the best condition. So in this study, it is based on four problem statement, which is the first one is high cost or expensive. So PLA is a high cost or expensive material is because it often used in a 3D printing that leads to the tremendous rise in demand and causes and it cause of the shortage of supply. Next is thermal deflection and strength. PLA, which is thermoplastic filament, commonly has low thermal deflection, and other than that, thermal properties, because of these thermal properties, it leads it into only usage of making prototype and modeling sample. For the third problem statement is thermal properties and rheological finding. So when the composite material is done its creation, the properties still remain unknown. So characterizing of properties should be done so that the temperature of 3D printer nozzle can be synced with the composite properties. Other than that, deformation of filament when it flow at different speed also should be observed. For the last problem statement is the high amount of plastic usage. So nowadays, the 3D printer when using the PLA, it is only use 100% PLA. So when the creation of composite material, it hope that the usage of PLA or plastic can be used for 100% at least into only 70% of usage. Next, we move on into the objective. So the first objective is to develop sugar palm fiber reinforced PLA composite through extrusion mixed with different treatment fiber and untreated fiber. So in the first objective, the process included is the two degrade of the fiber size, treatment fiber, which is now silane and now silane treatment, and finally is to extrude the filament. On the second objective is to characterize thermal and rheological properties of the composite. It is to answer the second last problem statement, which is to characterize the properties. So the process involved is properties test, which is TGA, rheological, and DSC. And after done the test, the properties of filament will be characterized. Now we move on into the research scope. The first one is sugar palm fiber as natural fiber, and polylactic acid PLA as the metric, and the size of the sugar palm fiber that needed in this journey is 125 micron, and the fiber will go through different fiber treatment, which is now silane and silane solution. Then it will, in this journey, it will use twin screw extruder, and the test involved is TGA, DSC, and rheological studies. And so there are a few literature or work that have been recorded before that can help in this study of composite material. So the first one is the combination treatment of alkali and silane has shown properties that are good for thermal properties. Next is the fiber loading was found to increase the thermal stability of the biocomposite. The sugar palm fiber that has been bleached with acetic acid and sodium chloride and alkali treated sugar palm fiber possess an advantage such as a better thermal stability. Then the fiber condition does give impact on the rheological behavior of hybrid nanocomposite polymers. Second last is when fiber content increased, tensile modulus shows significant improve in SPF HIPS compound, which is it will increase their strength, and adding weight of synthetic cellular fiber to PLA, which is also the natural fiber, the tensile strength can be increased 1.45 times, and the tensile modulus can be increased 1.70 times. So based on all this literature review, it can conclude that natural fiber really give good impact in creating a better composite, and also the fiber treatment also help into making the same result, such as the thermal stability will be increased, tensile modulus increase, and the thermal deflection also will be at the best. Now we moving on onto the methodology. There are a few methods that involved in the study. So the first step is to degrade the size of SPF. So it start with clean the SPF with tap water. It is to clean it from the foreign matter. Then it has to be dry under the sun or at room temperature. After it being dry, it has to be cut into smaller pieces into a size of 1 mm to 5 mm to avoid it is stuck into a crusher. So after it being cut into a smaller size, then it will be inserted into a crusher machine to turn it into a powder. So after being crushed by the machine, it will be moved into the sieve shaker that will separate the fiber into a desired size, which is 125 micron. The bigger size SPF will be inserted back into a crusher machine to be crushed again until it get into 125 micron size. So next process is treatment of fiber. So the first treatment is with alkali solution or NaO solution, which is to prepare the solution. We need to use 6% of the NaO or the alkali, and the balance of 94% only use water. So after the solution is ready, the 125 micron size of SPF will be soak for 2 hours into the solution and make sure it fully immersed. And after that, after 2 hours, rinse with the tap water to clean it from the solution, and it will be dry in an oven for 104 degrees Celsius for 24 hours. Next is a treatment with sealant solution. To prepare the sealant solution, we need 2% of sealant, add with 90% of methanol and 10% of water. Then it will be neutralize the pH by adding citric acid until the pH get 3.5. So the SPF will be immersed for 3 hours into the solution and rinse it with distilled water, and it will be dry up into the oven for 60 degrees Celsius for 72 hours. The next process is extrusion process. It will use twin screw extruder, and the fiber loading for each sample is 2.5% weight. So it will create 4 different sample, which is untreated fiber, a fiber that been treated with now, fiber treated with silane, and fiber treated with now saline solution. So after being extruded, the sample will be go for characterization of properties. So the filament of the fiber of the biocomposite fiber will be crushed into a smaller size again using a blender for this analysis. The thermogravimetric analysis and DSC calorimetry is for thermal properties analysis, while rheological study is for the rheological behavior analysis. So this is the result from the properties characterization. So the first one, we can see from the TGA analysis, we can see that the thermal stability at best when undergoes the two treatment, which is now plus sealant solution. The sample from this treatment, it need more energy to completely decompose it, which is it need the highest temperature, and from the data or the graph, you can see the untreated has the highest temperature. This is because the foreign matter that affect the result. What can be concluded from the analysis is that sealant can reduce glass transition temperature, and we also can see that melting point of now sealant is the best or the highest between the among the treated fiber, and crystallization temperature did not much effect, as we can see that the fiber or the temperature is almost the same between all 4 samples. Okay, on the last analysis is rheological studies. We can say that viscosity of composite or biocomposite has increased or higher when compared to pure PLA, and all the graphs show a shear thinning fluid pattern, which is declining, and the viscosity is declining and the shear is increasing. Okay, among all the sample, the best properties for rheological studies also goes to now plus sealant treatment sample, which is it has the highest or more forces that needed to deform the material at the different speed. Okay, there are a few things that can be discussed in this study. So the first thing is during the rheological study, the right amount of samples should be observed, because when the amount is not correctly put into the chamber of rheometer, it will affect the data or the result. So as we can see, the picture at above show difference between low amount of sample, which is on the left side, and a proper amount of sample on the right side. So during extrusion process, I have learned that freshly extruded filament must not go into straight into water to cool it down, because it can lead into drastically drop temperature that can lead into less mobility, which can cause brittle behavior. So based on the data that I've been collected, the sample that go through both treatment, which is now plastiline treatment, has the best properties or better properties than pure PLA or others sample. So this sample has the best thermal stability, which has gathered data from the DIC and TGA analysis, and it has the strongest intermolecular forces because it has been go through two treatment, and the last one, it has the highest shear rate that this is have been proved from the rheological data. Okay, on the recommendation part, there are a few things that can be recommended, which is study on mechanical properties to define its Young modulus, in plane shear modulus, measure positions ratio, and its ultimate tensile strength. Next is the fiber composition should be optimized, and determination of maximum fiber composition. Optimum alkaline solution and silane solution should also be measured, and the definition of composite density should be defined. And the last one is a scanning electron microscope. It is a type of electron microscope that produces image of a sample by scanning the surface with a focused beam of electron. It will produce a various signal that contain information about the surface topography and composition of sample. That's all, and thank you.